Okay, we are still looking at this grade distribution, which is quantitative or numerical data. Now we're going to look at the shape of this histogram. We're going to have a video for shape, one for center, the middle of the histogram, and one for the spread, how spread out it is. The first thing we look at with shape is how many bumps do we have? We call those modes. I know in 8th grade you learned that the mode was the most common number, but that's a terrible definition. If we look at our distribution here, 81 appeared twice, 88 appeared twice. But neither one of those was really a typical grade. When we say measures of center, mode, median, and mean, what we mean, or what was the typical, what was the average. And 81 and 88 were not average in any sense. So when we say this word in statistics, a mode, we mean a modal class, a bump or a peak in the histogram. And for us, that would be around here. Now that's always going to depend on what bandwidth you use. So we don't just stick with one specific answer and say, this is the mode. Our mode is, where's the hump? So I would say the mode is from 60 to 90. You may draw your histogram like this using a bandwidth of 20 and say 60 to 80. We're both right. And we would all agree that it's around here. What's important is how many modes we have. So a graph with only one major peak is called a unimodal distribution. Would look like this. A bimodal distribution would have two distinct peaks. In the real world, when you get a bimodal distribution, that usually means you have two groups intermingled that you really should be looking at separately. If we were to take all Valencia students and measure all their heights and graph out the heights of all Valencia students, we would get a bimodal distribution. Why? Because boys and girls have different average heights. We would get a peak for the average height for girls and a peak for boys. And when that happens in the real world, it's probably statistically better to separate those groups out and study them independently. If you have more than two peaks, we don't keep counting. There's no trimodal, quadrimodal. We just call them multimodal. And usually a multimodal distribution means your data is really just scattered all over the place. So there's one peak, two, more than two. The other choice is no peaks, a uniform distribution. Uniform does not mean everybody is the same. It means all outcomes are equally likely. If I were to roll a die 1,000,000 times and graph out how many times I got a 1, a 2, a 3, and so forth, I would get just as many 1s as 6s on average. Now maybe it wouldn't be perfect, but it would be pretty flat. Okay, the next thing we look at, by the way, our distribution is a unimodal distribution. We may have a couple of outliers here. We'll see later that these are outliers. Outliers are data points that just don't fit in. So these were the data points we can see up here, 5 and 23. They will turn out to be outliers under one definition. Next, we want to look at how symmetric our graph is. Could we cut it right down the middle and have two equal halves, or is it lean more to one side or the other? Graphs that lean, histograms that lean, we call skewed. And skewed goes the opposite way you think it does. The skewed side is the side with the longer tail. So this would be left skewed because it's got this long tail on the left. This would be right skewed because it's got this long tail on the right. Symmetric would be like a mirror image, one side to the other. Now, you'll never see perfectly symmetric, but you'll see close to it, and those you would just call nearly symmetric. Our graph is pretty clearly skewed left. If we include these outliers, if we were to ignore these two guys and only look at this part, I would say that's nearly symmetric. But if we include these, this is a skewed left distribution. Now we're going to talk about mean and median in the next video, but this is important to know. If you have a unimodal distribution, the mean will always be on the skewed side of the median. So in this distribution, the mean would be to the left or below the median. And also note that if we have a distribution that is unimodal, symmetric, and a roughly bell curve shaped, we'd say that is a normal distribution. So something that looks like this, we would say is a normal, or if it's close to that, a nearly normal distribution.